Hello guys, this is the second problem of homework 6. Segments A, B, and CD of the assembly are solid circular rods and segment BC is a tube. If the assembly is made of 6061 T6 aluminum, determine the displacement of end D with respect of end A. So first, I'm gonna do my section cut here, and then I have my normal, and then I have my 10 kilonewtons here. So doing sum of the forces equals 0, I have 10 plus n1 equals 0, so my n1 equals minus 10 kilonewtons. Now we're going to find the displacement of this first part. So I know my displacement is equal n1 times original length over area times modulus of elasticity. So this displacement 1 will be minus 10 times 10 to the third, to put in newtons, times 435 millimeters over area, pi over 4 times 0.02 square, to put in meters, times 68.9 times 10 to the 9 pascals. So our displacement 1 will be minus 0.2 times 10 to the minus 3 meters. So this is our first step. Our second step is made a section cut here. So now we have our piece, something like this. Here we have 10 kilonewtons. Here we have 10 kilonewtons. And here we have 10 kilonewtons. And here we have our N2. So the sum of the forces equals 0. We have N2 plus 10 minus 20 equals 0. So my N2 is equal 10 kilonewtons. Now we're going to find the displacement of this part. So our displacement is equal N2 times L over area times modulus of elasticity. Recall that this part is here, section AA. So my area will be pi over 4 times 0.04 square, that's our outside diameter, minus 0.03 square, that's our inside diameter. So I have my modulus of my displacement for this part is 10 times to the third times 435 millimeters over area, pi over 4 times 0.04 square minus 0.03 square times my modulus of elasticity, that's 68.9, 10 to the 9 pascals. Now our displacement is equal plus, because we have like a positive N2, is 0.115 times 10 to the minus 3 meters. Now we can do a section cut here, and then I'm gonna use, just like in our previous exercise, here I have 20 kilonewtons, and here I have my N3. So I know the sum of the forces is equal 0. I have minus 20 minus N3 equals 0. So N3 equals minus 20 kilonewtons. If you want, when you do the displacement, you're going to put N3 times L over area times modulus of elasticity. we know here is minus 20 times 10 to the third times 435 millimeters over pi over 4 times 0.02 square times 68.9 times 10 to the 9. So my displacement is 2 times or almost 2 times is because of the sig figures, is not 2 times like 0.4, is 0.402 millimeters times 10 to the minus 3 millimeters. So our total displacement is equal displacement 1 plus displacement 2 plus displacement 3 that we just found. Here is minus. So our total displacement will be minus 0.2 plus 0.115 minus 0.402 times 10 to the minus 3 10 to the minus 3 in all of them. So my final answer is the all displacement is minus 0.488 times 10 to the minus 3 meters or minus 0.488 millimeters. So this is our second problem of homework 6.